Hi, good morning again, class. Ang agenda natin for today is i-discuss yung mga problem set na mga ginawa natin, and then probably from here makakuha tayo ng a few bits para naman makapag-ano kayo sa exam. Ma-refresh kayo sa exam. Okay. Okay, sige. Let's start with problem set number 3. Isa-isahin lang natin. Okay. Okay, so meron daw tayong wire, 2.5 meters in length, tapos meron siyang typical household current, which is around 1.5 amperes. Okay? Tapos nakapwesto siya na-experience niya yung magnetic field na 0.55 Gauss from south to north. And then, what is the magnitude and direction of the force na ina-exert nung magnetic field doon sa current if it is running from west to east, vertically upward, and then from north to south? Then letter D would be asking if it does if it is negligible or hindi. Okay, so first gusto natin gawin ay lipat muna natin lahat ng unit sa SI. So 0.55 Gauss. So 0.55 Gauss is 55 times 10 to the negative 6 Teslas. Okay, so proper scaling lang. Lipat tayo sa proper scaling para we can use directly our equations. Okay, so we are asked ano yung force. So in general, pag meron kang current, may current ka, tapos may magnetic field ka, di ba? This is IL cross B. Okay? Okay. So yung B natin runs from south to north. So we have a magnetic field that's going this way. North, south. And then, yung unang tanong would be from west to east yung current. West to east yung current. So by the right hand rule, galing ka muna sa current. Right hand ka papunta sa, curl mo yung mga fingers mo towards the magnetic field. Okay, so yan. Therefore, yung thumb mo naka-point out of the page. So, for A, F is out of the page with the magnitude of 2.1 times 10 to the negative 4 newtons. Okay, so it's wise if pag nagsosolve kayo ng mga forces, ganyan, yung mga direction, pwede nyo gawin is i-positive nyo lang muna yung mga bagay-bagay. Okay. So, kunin nyo muna yung positive values ng mga things, tapos by your analysis na lang yung yung direction. Okay? So again, dahil to the right, to the east yung current, so curl mo towards papunta kay B. Therefore, yung thumb mo naka-point outwards the page. So we have this. Okay. Okay, kasi ito ay nakuha by plugging in I. Tapos yung length, which is 2.5 meters. B. Then sine theta. Yung theta ay 90 degrees. Okay. Okay. So again, let's proceed. Letter B naman. B naman is vertically upward. So we have the magnetic field going up, north, south. Tapos the current is pointing vertically upward, so towards us, out of the page. Out of the page yung current. Therefore, if you're going to use your right hand rule, yung direction ng current would be this way. Okay. Okay. With the same magnitude, the same values na ng mga bagay-bagay. Okay, 90 degrees pa rin naman yung separation ng angles nito, yung vertical vector, tapos towards the north, so yung angle ng dalawang vectors na yun ay 90 pa rin. So you have the same figures. And then lastly, see, if we have here, north, south, tapos yung wire yung current natin would be running from north to south. Okay. So they are parallel. So wala mangyayaring cross product. Zero yung cross product mo. So zero. Then D is malaki ba yung magnetic force para magkaroon ng significant effects sa mga bahay-bahay natin. Napansin nyo naman, wala pang 1 Newton yung force niya. So wala siyang significant effect to us. Okay, so that we're done with that. Okay. Next is meron tayong rod dito, conducting wire na nakalagay doon sa isang inclined plane. Okay, tilted by an angle theta. Okay, kung side view titingnan natin. Side view. Tapos meron kang wire. And then meron kang magnetic field that is pointing upward. Okay, hindi ko nag-drawing yung maraming electric field, magnetic field, no? Drawing ko na lang yung nakatutok sa kanya, which is upward. B. Okay. And then, pwede tayo mag-supply ng voltage, pag-supply ng current dito sa wire natin to make it not fall sa inclined plane natin. Okay, kasi 'di ba pag nag-run through yung current dito and then perpendicular si wire tsaka si magnetic field, alam natin may force somewhere depende dun sa direction ng current na supply natin. Okay, so with the right amount of current, hindi ito malalaglag sa inclined plane. Okay. So by the right hand rule, gusto natin yung current coming out of the page. Ganyan. Kasi pag ginawa mo yung right hand rule, ang lalabas na force ay towards to the left. Okay? Siyempre, pag to the right yung force, malalaglag siya lalo, di ba? So with this, ito yung gusto natin. Okay, drawing ko lang na mas maayos. So we want this force to be something like this. And then you have to counteract the force that is due to its weight. Like this. Okay, so this force is due to gravity. Ito naman due to the wire. So F ILB. Okay? Since 90 degrees naman, so sine 90 is just 1. So shorthand ko na I times L times B. Okay, si L ay given, which is L, capital L. So, sulat pala natin yun, no? I, capital L, B is given. Okay. Okay, so from here, meron tong angle na same lang din dahil by geometry, di ba? Parallel itong line na to sa ground. Okay, so that theta is there. Same yung theta nila. Okay, and then another one, if we're going to get the perpendicular line to this inclined plane, yung angle between the force of the weight, the weight. Okay, this is also theta. Okay. So, gusto natin kunin yung parts ng force that will go through here. Ay, sorry. And go through there. Para alam natin kung sino nagkokontrahan. Okay. So, meron tayong dalawang right angles. So, drawing natin yun. Meron kang ganito. So, this one is the F is equal to ILB na tsura. Okay? So, ayun yun. Ito yung part na yun. Inikot lang natin para mas madali natin maintindihan. Okay? So, yung force na nandito, kapag bin-breakdown natin to, pwede natin kunin yung F cosine theta and then F sine theta. Okay? So, pag bin-breakdown mo to, pag minultiply mo siya ng cosine at sine, ilalabas na forces would be itong mga nasa axis mo. Okay? Okay. So, important sa atin dito would be yung katabi ng angle kasi ito yun. Ito yun. Ayun yung force na yun. Okay. So, sa kabila naman, punta tayo sa kabila. So, we have our axis. And then, okay. Kabaliktaran naman ito. Meron siyang mg. With angle theta na dito naman. Okay, so ito yun. Yung part na yun. Nilipat ko lang yung drawing. So therefore, yung FG, lagyan natin FG. FW. Okay. So yung force na nandito is FG cosine theta. Kabila naman would be FG sine theta. Okay, so yung mahalaga sa atin for this part naman is yung malayo sa angle, itong part na to. Kasi ayun yung kukontra dun sa kabila. Okay, so sila yung nagkokontrahan. Okay, so yung part na yun, ito. So therefore, para hindi gumalaw yung wire, dapat equal yung forces. So therefore, we need FW cosine theta must be equal to FG sine theta. And FW cosine theta is ILB cosine theta mg sine theta. Then you need your I, the current being supplied, to be mg over lb sine divided by cosine, that's tangent. Okay, so ito yung kailangan yung amount ng current na isusupply mo. Nice. Nice. Okay. So, ang hirap ng mga probset, no? Feel ko ang mas mahirap yung mga probset cases sa mga exam questions. Okay. Next, problem set number 4, 28.63. Okay, meron kang, tingnan natin yung mga units muna. 1 meter. Okay, so mga meters naman yung mga distances. Currents is in terms of amperes. Okay, yun lang. Okay, so yung anong kailangan natin sa problem na to? Sa problem na to, kailangan natin ng ganitong formula. Formula ng magnetic field due to a straight wire, which is mu naught I over 2 pi R. Okay? So, ito ay gamit lang yung Ampere's law. Ampere's law. Okay? Okay. So, what is the magnitude of the magnetic field at P due to I1? Okay, so B1 so at P, si nakakaranas si P ng magnetic field na galing kay 1 by an amount of mu naught I1 over 2 pi. So the distance from the wire to the point. So that's 1 meter plus 0.5. So we have 1.5. Okay. And then by the right hand rule, this points downward. Okay. So into the page yung current. So yung magnetic field, yung current yung pupuntahan ng thumb mo, tapos yung curling fingers mo yung direction ng magnetic field. Okay, so pag tinry mo yan, pag ganun yung pabilog yung magnetic field. So at this point, pababa siya. Lagyan natin ang down. So ang tanong sa atin sa una, ano raw yung susupply natin kay I2 para maging 0 yung net field sa P. Okay? So therefore, dapat at B2, si B2 may produce siya na mu naught over I2, 2 pi times 0.5 lang. Diba? Kasi 0.5 lang yung distance ni I2 kay point P. Therefore, we want B1 to be equal to B2. In magnitude at least. So that's mu naught I 1 over 2 pi 1.5 must be equal to mu naught I 2 pi 0.5 mu naught cancel yung mga mu naught 2 pi. Therefore, I2 must be equal to 0.5 over 1.5 ng I1 or 1/3 I1, and I1 is 6 amperes. So we have 2 amperes current for I2. Okay? Okay. Tapos, ano yung direction, no? Para mag-cancel sila, kailangan this is upward. And to produce that, dapat out of the page yung current. Okay? So, out of the page yung current. Ayan. Okay. So, using this amount of current, what will be the magnitude and direction of the net field at Q? Okay, at this point naman, so you just have to do things systematically. B1 at that point would become B not I1, ganun pa rin kung ano mga values nila. 2 pi, magbabago lang yung denominator which is 0.5 distance. Okay, then let's determine the direction. The direction naman at this point would be upward. Okay, upward naman ito. And then for B2, since out of the page siya, downward yung force, tapos distance 1.5. 1.5 downward. And then you just need to subtract these two. So B1 minus B2. Okay. Now, if this is greater than 0, therefore, upward yung upward yung direction ng resulting. If it is less than 0, ibig sabihin na naig yung nanalo yung B2, no? Therefore, downward. Okay? So, kapag negative yung nakuha mo sagot dito, you take the positive of that, tapos sabihin mo na lang na downward yung direction. Okay? So, however, this is upward. Dapat positive makuha nyo dito. So, B1 minus B2 is around 2. This is equal to 2.13 times 10, around this number. Teslas. Okay? And then lastly, for the point S, okay, so point S naman would be a similar process. Meron kang u naught I1 over 2 pi times yung distance niya dun sa point na tinitignan mo. So, 0.6 meters daw yung distance niya. And then, if you're gonna do your right-hand rule, the magnetic field there points this way. And yung sa kabila naman points this way. Okay. So, 0.6. Tapos, pag ganito siya, then B2 ko would become u naught I 2 pi 0.8 pag ganyan naman. Okay? And then, how do you get the resulting amount, no? Resultant amount of this magnetic field. Okay, so first things first, kailangan malaman yung angle between those two between those two vectors. Okay? So yung isa pa ganun, isa pa ganun. Okay. So meron naman tayong values nung nung lines connecting the triangle. 0.6, 0.81. Okay? So kapag ganyan, given ka ng ganyan, tapos you might want to use your law of cosines. No? Law of cosines. Paano ba yung law of cosines? Kung naalala niyo pa. So the longest side must be equal to the short side plus the long side. Tapos minus 2AB cosine theta. So malalaman mo yung theta, no? Between A and B. Ito yung law of cosines. Okay. Pero you can always brute force things. Tingnan natin muna kung ano yung relationship ng 0.6 sa 0.8. Ito may brute force naman. Tingnan natin by Pythagorean theorem kung gagana. Tingnan naman lalabas dito. So lalabas dito is 1. Nice. So therefore, square root nito yung yung length ng kabila. Okay, so 1 lang din. And it turns out, 1 din naman. Ibig sabihin, 0.6 and 0.8 are in right triangles, right angles with each other. Therefore, these guys, yung total mo, would be simple. By ano rin sila, Pythagorean theorem yung resulting. Okay, so you do this, and the total is around 2.06 times 10 to the negative 6 less. Okay? Okay. So you have that. Okay. Next is this part. Meron kang circular loop. Tapos meron kang loop of straight wire. Okay. Si circular loop mo meron siyang current running clockwise. So therefore, yung magnetic field mo, by the right-hand rule, with your right-hand rule dito, kasi pag ganun lahat ng magnetic field into the page. Okay. So, ayan, into the page yung magnetic field due to 2. So, drawing natin, B2 is into the page. And then, if we're going to... Okay, ano muna yung tanong sa atin? Okay, so yung center daw ng loop is at the distance D from the long straight wire. Ano raw yung magnitude and direction of the current I1? If we want to zero out the magnetic field at the center of the loop. Okay, so syempre kung gusto mong maging ganun, dapat kukontrahin mo si B2, which is gagawin mo na out of the page yung magnetic field due to I1. Therefore, you need to run the current to the right. Okay, so let's compute. So B1 madali lang. This is again unit I, 1 over 2 pi. So yung distance ng wire doon sa center ng loop is D. And then, okay, we have this. Sa B2 naman, it's not very simple, but you can always grab the result from your book. So B2 in general, it looks like this. Mu naught I2 times the radius squared divided by 2 x squared plus r squared is 3 halves. Okay? So yung x is the distance. Yung x yung distance from the center with respect to the axis. Okay, so if you look at this point, kung mag-go into the page ka, tapos titignan mo kung gaano kalakas yung field dun. Okay, magbabago yung x. Okay. Pero kung nandun ka sa center ng loop, ibig sabihin x is equal to 0. So we plug in that. We have mu naught I 2 r squared 2 3 halves ng r2. Okay. So yung 2 cancels out with the outside exponent. So r cubed na ito. Therefore, we can simplify further. R squared over r cubed. So that's 2r. Okay, now we have our equations. We just want them to zero out. Ibig sabihin, mag-equal dapat sila. So B1 must be equal to B2. Okay. Mu naught I1 over 2 pi d must be equal to mu naught I2 to r. So we can cancel mu naught 2 mu naught over 2. Therefore, my I1, the current I need to run through the straight wire is I2 times pi d over R. Okay. Simple. Dali lang, di ba? Okay. Next is 28.73. Medyo may thinking na ganap dito. Okay, let's consider the slab. Tapos pili tayo ng isang current sa gitna. Current ka dyan. Then may current ka ng 1 unit to the right, 1 to the left, and so on, and so on, and so on and so forth. Okay? So suppose you want to look at this point. You want to look at the magnetic field at this point. Okay? Tapos, tingin ka sa mga katabi mo, ano yung pinoproduce nilang magnetic field towards that point. Okay? So, may katabi ka na dalawa. Isa to the right, isa to the left. And the current is going out of the page. Therefore, yung mapuproduce na magnetic field nito at that point, at the green point, is going this way. So yung ano muna, yung nasa left yung kukunin ko. So, may the right hand rule, parang papunta siya dito. Somewhat like this. And the other one, medyo pa ganun lang. Okay. Ipapansin nyo, since this is the same distance, therefore, yung angle nila, same lang din sa angle nito. And adding those two will zero out. Actually, hindi mag-zero out, no? Magpupunta siya sa ganitong direction. Okay? Sorry, pangit yung line. Yung resulting force, resulting magnetic field is going that way. So, syempre, pag inulit mo yung process sa kabila, kabaliktaran lang na direction. You have forces like this, you have forces like this. Okay? So, ulit-ulitin mo sa mga katabi mo, kada pair na currents. Ganun lang din yung mangyayari. Tapos yung sa sarili mo, to the left din. Okay, or to the right. Kasi by the right-hand rule, ganun makukuha mo. So in essence, we have a magnetic field going this way and magnetic field going that way below. Okay, now you can use Ampere's law. No? We can use Ampere's law. Ipo-close lang natin tong loop na to. Okay? So yung vertical lines, wala namang ambag kasi wala naman tayong magnetic field doon. Okay, so assume natin na this length here is L. So therefore, we have dl. So for our case, ilan yung mga may magnetic field? So L, 0, another L, 0. So that's 2L. Okay. Usually, ginagamit natin Ampere's law kahit pagpabilog, di ba? Pabilog. Tapos, lahat yun may magnetic field contribution. Kasi usually, pabilog yung mga magnetic field natin. Pag galing sa straight wires, ganyan, di ba? Usually, may ambag lahat yun, kaya 2 pi r yung gamit natin. Okay? So, for this case, ang kailangan natin 2L lang kasi wala namang ambag yung dalawang gilid. Okay, and then this must be equal to mu naught I enclosed. Okay, so we need to figure out kung ano yung I enclosed. So I enclosed would be the currents na napasok dito sa square na ito, sa rectangle na ito. Okay, so let's look at the given to us. So there are n conductors per unit length. Tapos kada conductor, they carry current I. Okay, so I enclosed must then be mu naught. So ito ay I times the number of wires per unit length. And syempre, per unit length pa siya, mumultiplyan ko pa ng length, which is L. Okay? Therefore, our magnetic field is isolating B, mu naught I n over 2. Okay, cancel si L. So therefore, yung magnetic field ko above is going to the left and below is going to the right. So in formal terms, B is equal to mu naught I n over 2. Positive kapag z greater than 0, x hat, and then mu naught I n over 2 negative x hat when z is less than 0. Okay? Z kasi nasa baba eh. Yung positive z nasa baba. So therefore, yung negative 0, negative 0. Yung less than 0, itong region na to yung nasa above the plane of currents is going to the left, which is yung left natin in this sense is negative x. So you have this. Okay, enough of that. Sagutan naman na natin na. Okay, so itong next part is very important. Maraming questions sa exam nyo. Induction, mga ganyang bagay. Ampere's law. Okay. So, let's proceed. Meron tayong current I. Tapos, constant yung current. And then we have 4 conducting loops, A, B, C, and D, which are moving near the wire. Okay. So, tingnan muna natin yung mga directions ng magnetic field natin. So, yung pink with yung pink na symbols would mean that these are coming from the current. So, by the right-hand rule, yung current ay yung magnetic field dito is out of the page, into the page. Okay. Okay. So next, tingnan natin yung current, magnetic field due to the wire, which is B mu naught I over 2 by R. Okay, ibig sabihin lang nito as you go away from the wire, malaki yung R, lumiliit yung value ng magnetic field. Okay? So mas malakas yung magnetic field kapag mas malapit ka sa current mo. Okay. So let's understand these motions. Okay, let's start with A. Okay, so si A going away from the wire. Therefore, B decreases. So, nilipat ko sa pink, no? Kasi this is due to the, ito yung field na to yung galing doon sa straight wire natin. Okay? And then, nature doesn't like change. So, ang gagawin nung A mo, the loop of wire, is to induce, is to react with increasing B. Okay, so nawawala yung field as you go away from the wire, and that change we don't like that. Nature doesn't like that. So gagawin niya, magre-react siya with increasing B. So ibabalik niya yung nawawala. So therefore, ang direction ng induced current then is out of the page, no? Kasi nawawala yung out of the page na field. So therefore, ibabalik niya yung out of the page na field. Okay? Okay. So therefore, to produce this current, to produce this field, the current needed is counter clockwise. Gawin ko na lang CC. CC. Okay, next is B. Okay, si B, mapansin mo, papalayo din siya sa wire mo. So, B decreases. Okay, and then yung nawawala sa kanya ay into the page. Okay. Therefore, magre-react yung loop of wire in similar way. And then, syempre, nawawala ay into the page. So, ibabalik lang yun into the page lang din. So, therefore, to produce that kind of field, you need clockwise motion. Okay? Next, C. C, okay. So, walang nagbabago sa field ni C. Walang nagbabago sa nararamdaman ni C due to the current. Okay? Kasi hindi ka lumalayo, hindi ka rin lumalapit. Okay, so 0. No induced current. Okay, lastly is D. Ang nangyayari naman kay D ay B increases. Tapos yung direction niya into the page. So, magre-react react with yung current loop natin with decreasing B. Kokontrahin niya yung increase. So, therefore, para makontra niya, kabilang direction naman yung gagawin niya. Okay? So, to do this current, to do this magnetic field, kailangan mo ng counterclockwise na current. Okay. Now, tanong sa atin, for each loop, what is the direction of the net force that the wire exerts on the loop? Okay. So, again, pwede mo gamitin yung idea from Lenz's law that nature doesn't like change. So, si A, papalayo siya sa wire. So, ang gagawin ng nature, ibabalik niya so, sige, sulat muna natin yung mga results using Lenz's law. Attract i-attract niya. B, i-attract niya rin. Kasi papalayo sila. C, wala. No, nothing. D is repel. Okay, so si D kasi papalapit siya, di ba? So ayaw ng nature na may change tayo. So tutulak niya lang pabalik. Pero not satisfying yun. Not satisfying ng mga pag-solve of things. So gamitin natin yung mga result natin dito. So yung una natin, mayroon kang counterclockwise current. So drawing natin. Counterclockwise. So pag ganun ka na current. Induced. Okay. And then tingnan mo ngayon yung direction of the current that is nearer to the big wire. Okay, so in this point, drawing lang din natin dito. Ganyan siya. So mas malapit itong part na to dito sa wire na ito. So parallel wires attract. Okay. So therefore, ayun yung ano natin. Yun yung mas magandang basehan. So attract. So mas malakas kasi yung force na mas malapit dun sa ano. Kung gagamitin mo yung IL cross B. IL cross B. Okay, so mas malapit yung wire na to. Mas malakas yung mararamdaman niyang field dahil mas malakas yung force na mararamdaman niya kasi mas malakas yung field pag mas malapit ka. Okay? Okay. Sa B naman, clockwise. So, pag ganun, clockwise. So, therefore, parallel currents pa rin. So, they would attract. And then, for this part, pag ganun naman siya. Okay? Papansinin mo, anti-parallel na ngayon yung direction ng currents. Therefore, they would repel. Okay. Okay, wait lang. Okay, I'm back. So, ayan. Tapos na tayo sa problem na to. Okay, so dapat na-explain yun, no? Mga yun. So, give your reasoning. Okay. So, meron daw tayo, in this problem, meron daw tayong magnetic field in this region, circular region. Uniform in space. So, lahat dito sa region na to ay uniform, yung magnetic field. Then, if the magnetic field is increasing with the rate of dB over dt, what are the magnitude and direction of the force on a stationary positive point charge Q located at points A, B, and C? Okay. So, changing magnetic fields also induces electric fields. Okay, and then in the same way, changing electric fields produces magnetic fields. So, from here, dapat meron tayong ma-feel na induced electric field. Okay, but things are not so very intuitive. So, let's try to make things simple. So, let's assume na meron akong wire dito. Okay, meron akong wire dyan and to produce this kind of setup that we have into the page ka na magnetic field. So therefore, I would have this kind of wire to have a current running clockwise. Okay? Running clockwise. Then let's assume another again. Let's assume that another wire is here. Sige, kaya ko to. Para bilog mo. Yan. Let's assume na meron kang another wire in here. Okay? Okay. So Kapag dinagdagan ko yung magnetic field in this region sa inside, di ba sabi, increasing daw with the rate of dB over dt. Therefore, I just increase the current. Tama ba? I increase the current, I increase the magnetic field, and increasing magnetic field induces a current through this wire. Okay? So, ayaw ng nature ng change. So, kung nag-i-increase yung into the page na magnetic field, yung wire natin na green would counteract that. They'll counter that magnetic field. So, ang mangyayari ay magkakaroon siya ng counterclockwise na current. Okay? So that it can produce a field that is going out of the page para ma-cancel na yung increasing into the page. Okay? And then, syempre, nagkaroon ka ng current sa wire, no? Sa loob ng wire. Nagkaroon ka ng current sa loob ng wire. Therefore, nagkaroon ka ng electric field inside that wire. Okay? Okay? So, nagkaroon ka ng electric field inside that wire. Now, in a similar way, ganun yung interaction ng increasing, ng changing magnetic fields. No? So when you change kapag may wire ka, yan, you increase the current, you change the current, you produce a magnetic field that is circulating around. Tama ba? So changing the currents means changing the electric field. Okay? In the same way, in the same manner, kapag meron kang linear na magnetic field, yung electric field na induced naman, syempre, kapag in-increase mo yung magnetic field, dapat meron kang kaakibat na change in electric field, and then lalabas dun ay paganito. Okay, so magka-partner lagi sila. Kapag yung isa naka-curl, yung isa nakabilog, yung isa naman straight line. Kapag isa straight line, isa naman nakabilog. Okay, bakit pa ganun yung direction? Kasi, di ba, Faraday's law, negative yung. Okay? So, ang kailangan talaga natin formula dito is very straightforward. Binigyan ko lang siya ng interpretation para lang na may appreciation tayo sa mga mathematical bagay-bagay. E.dl tapos, kunin ko lang yung magnitude muna. May negative sign dito pero baka malito kayo. So, I take na magnitude. Ito yung kailangan natin. Okay? So, whenever flux changes, you have an induced electric field. Or when the magnetic field changes, meron kang induced electric field. Okay? So, this part here, kukuha ka ng bilog, 2 pi r. Okay? So, kaya na tayo nag-imagine ng circular wire sa loob para hindi mahirap sa imagination natin na merong umiikot na electric field dito. Okay? And then, this is just B times A. And we know dB over dt. Okay? And then A would be the area of the closed path, which is pi r squared. Okay? Therefore, the electric field in the region r over 2 dB over dt. So, meron kang electric field here going counterclockwise with this amount of magnitude. So, ng forces na matatanggap ng charges mo would simply be QE. Okay? So, si A would experience a force going to the left. B, yung B ko would become upward. And syempre, yung C, 0. Kasi wala siyang radius. So mag-zero out lang tong equation mo for the electric field. Okay. Now, let's last Probset. So, tapos na ba tayo? Tapos na, no? Okay, magnitude and direction. Okay. Problem set number 6. Okay, a toroidal solenoid with mean radius R and cross-sectional area A. Merong N1 turns. Tapos meron tayong second toroidal solenoid with N2 turns na binalot doon sa unang toroidal solenoid or toroid. Mas madali yung toroid. Nakakalito pa yung toroidal solenoid kasi baka maisip mong solenoid siya. Okay, so para daw yung dalawang toroids, may same cross-sectional area and mean radius. Okay, so tinatanong sa atin what would be the mutual inductance of the two solenoids. Okay. So either way, you can use pwede kang bumase doon sa unang toroid or doon sa pangalawang toroid. So let's put that into math. Okay, so yung magnetic field first ng toroid is given by mu naught, the number of turns, the current it handles, and then 2 pi r. Okay, 2 pi r. This is the general form of the toroid magnetic field. Okay, so the mutual inductance is given by depende, no? Kuwari, nakabase tayo kay toroid number 2. Then this is the thing. Okay. Pwede rin naman yung kabila, which is N1, B1, and then I2. Okay. So, either way, parehas lang. Okay, so let's do this. Hanapin muna natin yung flux due to B2. Flux to B2. B2. No? Flux to number 2 yan. Flux to number 2. Okay, so flux due to number 2, the toroid number 2, is given by yung magnetic field due to 1 plus area ng pangalawa. Okay, so magnetic field nung unang toroid would be mu naught N1 tapos I1 divided by 2 pi r tapos times yung area. Okay, so with this, plug in lang natin dito. Let's write it down here. M is equal to N2 times yung nakuha nating sagot, which is mu naught N1 I1 cross-sectional area ng 2. Well, equal lang naman dalawang cross-sectional area nila, diba? As detailed out in the given. Kasi closely wound daw sila. Then all is divided by I1. Therefore, this cancels out and we have the mutual inductance to be mu naught N2 N1 A2 over 2 pi r. Okay? So that is the mutual inductance of the two solenoids. And then if we are to plug in these values, N1 is 500 turns, N2 300 turns, R is 10 centimeters or 0.1 meters. Tapos an area of 0.8 cubic square centimeter. So ita-transform mo pa to, no, into square meters, which is not very straightforward. What is the value of the mutual inductance? Okay, so plug in natin lahat yung values na yun. And you'd actually obtain 24, around 24 microhenries. Okay, nice. Okay, and then lastly, inductance ng solenoid, self-inductance niya. So alam naman natin na yung solenoid, yung magnetic field niya is mu naught, the number of turns times the current I, and then divided by the yung length. Okay? Or in some given, kapag given ka na ng number of turns per unit length, small n, ito siya. Okay? Ito yung small n, number of turns per unit length. Okay? So, ano raw yung self-inductance? So, the self-inductance is given by L, which is just the number of turns, the flux with itself, and the current I. Okay? So, that's recta na. N over I. The flux with itself would become kopyahin natin yung magnetic field due to the solenoid times some area. Okay. So, I cancels out. Then you have mu naught n squared times A over L. So, that's, okay, ayun yung kailangan natin. Okay, kasi in-assume din ng magnetic field is uniform inside and zero outside. Okay, so yung total flux mo lang would be the field over the cross-sectional area, times the cross-sectional area of the solenoid. Okay, and then B would be plugging in values for your self-inductance or inductance. So 5 cm and 0.15 centimeter, lilipat mo pa sila into meters. So, ano raw yung self-inductance kung n yung mga values? Okay, so plugging things in, this is actually around 0.11 microhenries. Okay? Okay. So, that's your, that's all of your probsets. Tama, di ba? Hanggang 6 lang. Okay. And let's have a rundown ng mga topics na kailangan yung pansinin. Let me just whip up the book. Okay, so yung start ng aral nyo is from chapter 27 to chapter 30. Okay. Okay, and then, syempre, sa magnetism, kailangan nyo yung idea ng magnets that they always come in bipoles. So, dalawang pole, walang monopole na magnetic, walang magnetic monopole. So, walang north na north lang, walang magnet na north lang, walang magnet na south lang. They always come in pairs. Okay, and then you need the imagination sa mga magnetic field. Okay, kailangan na-imagine sila by the right hand rule. And then magnetic forces due to charges. Okay, so QV cross B, that's a needed one. Then, imagining the magnetic field lines. Okay, so magnetic flux ay 0 para sa isang closed area. Okay? Kapag closed surface. And then, motion of charged particles in a magnetic field. Kailangan yan, cyclotron motion. So, yung radius, kailangan yun. Depende sa velocity and the magnetic field. Okay, and then basahin niyo yung application ng application of motion of charged particles. Then, of course, kita nyo naman sa Probset na kailangan ng IL cross B. So, kailangan din yan. Force and torque. Yes, kailangan ito. So, torque is just the magnetic dipole moment mu cross B. So, yung mu ay yung yung I times A. Okay, for a closed loop of current. Sa libro naman. Energy, yes. Direct current motor, hindi nyo kailangan to. Hall effect, hindi nyo rin kailangan to. But if you're curious, syempre, I wouldn't stop you from reading those. Chapter 28, magnetic field of a moving charge. Tapos, baka gumamit ng mga equations na baka gumamit ng mga relations ng magnetic field doon sa yung mga straight conductors na hindi mahaba. Baka lang naman. Nasa libro lang naman, basta alam nyo kung saan nyo siya hanapin. Wala namang integral sa exam. Okay, and then forces between parallel conductors, yes, kailangan nyo to. So wala na, para mas mabilis yung calculations nyo. Magnetic field of a circular current loop, yes. Nandito naman yung equations, no need to do the integrals by yourself. And then, Ampere's law, marami. Maraming Ampere's law. Okay, maraming Ampere's law. Magnetic materials, wala akong binigay. Electromagnetic induction, napakaraming tanong dito. Lenz's law, yung mga direction, counterclockwise, clockwise. And then, let's have something like this. Okay, kunwari meron kang magnetic field na ganito. Okay, baka lang magulat kayo sa exam, ano ibig sabihin nun. Kunwari meron kang magnetic field that is into the page. Okay, so pag sinabi kong counterclockwise with respect to the magnetic field, so dapat yung thumb nyo nasa direction ng magnetic field, tapos yung hands nyo, yung fingers nyo yung magde-decide ng counterclockwise. So right hand rule siya. So pag sinabi ko yung counterclockwise in this sense, clockwise siya talaga. Okay, clockwise siya. Okay, kasi with respect to the magnetic field, no? So yung magnetic field is pointing towards the page. So if you're gonna do the right hand rule, ito yung counterclockwise. Okay? So when you have another magnetic field, ano yung counterclockwise? Ganito siya. Okay? Okay, okay? So, yung thumb nyo lagi nasa magnetic field. Tapos, yung curl ng fingers nyo would be the counterclockwise. Kapag sinabing with respect to the magnetic field. Okay? Counterclockwise with respect to the magnetic field. Okay, share nyo lang sa klase nyo para hindi sila maguluhan sa buhay nila pag nakita nyo yung exam. Okay, and then Faraday's law, syempre, kasama yan nung kasama yan ng induction. Then motional EMF, yes, included din ito. Induced electric fields. Alam ko nagbigay ako nito. Okay. Displacement current, parang wala. Eddy currents, wala din. Superconductivity, wala rin, I think. And then inductance, yung mutual and self-inductance lang naman. Tapos, relationship ng inductors kapag naka-series and parallel. Tapos may binigay din ako, magnetic field energy. So, yung mga 1/2 Li squared. And yes, that's it. That's it. So, any questions na gusto nyo i-consult para sa exam nyo on Saturday? Yung oras ng exam to be announced. To be announced. Okay. Okay. Any questions? Wala. So, kung meron, you can always consult in Canvas. Okay, kung na-curious kayo sa isang bagay, sa isang problem sa libro, hindi nyo alam bakit ganun, you can consult it. Okay? So, that's it for today. Upload ko tong meeting naman para ma-take in nyo slowly yung problems at solutions kung naguluhan.